Hello everyone, welcome back to this webinar. This series is all about machine intelligence and modern infrastructure. Every alternate week, I bring you one of the webinars covering the machine intelligence or the modern infrastructure track. So the MI2 webinar series attempts to bring various technologies from the domain of artificial intelligence, IoT, edge computing, of course, Kubernetes, containers, microservices, and so on. Essentially, we have two tracks. One is the infrastructure track and the other one is the intelligence track. And today's session is about infrastructure and an emerging technology in the space of microservices called as service mesh. I have covered Istio in depth. I had a couple of sessions. You can find that in my YouTube channel. I also covered Linkerd last month. And this month, I'm pretty excited to bring you another service mesh called Consul. So what are the objectives of this session? Well, I'm going to give you a quick overview of the service mesh, why we need service mesh, and in case you have attended my previous webinars, you would be able to relate to that. This is a continuation of the track that I've been running around service mesh. And then we'll take a closer look at Consul, and then we will look at some of the use cases, especially service discovery, Consul Connect, and the service discovery, the DNS part of service discovery. And I have a very comprehensive demo. So even if you are not very familiar with Consul or service mesh, you will be able to get started right after this. And there is a complementing article, a tutorial that is already published at the news stack, and another part of that tutorial is scheduled to go live tomorrow. So if you're watching this on YouTube, you'll be able to find the link to the article and the tutorial in the description section. So before I go any further, let me bring up a quick poll to make sure that you're able to look at my screen and listen to the audio. So I'm launching a quick poll, and let me know if you're able to listen to my voice and see my screen. Perfect. Looks like everyone is able to follow this. Fantastic. Uh, I have another quick poll. This is about your understanding of service mesh. So let me know if you have used any of the mentioned service mesh technologies, or feel free to choose the last one if you have never used a service mesh. All right. Looks like most of you have never used a service mesh. That's absolutely fine. I'm going to set the context and then walk you through the basics of Consul. So stay tuned, and this is going to be an interesting session. All right. So microservices are real. Thanks to Kubernetes, thanks to containers, microservices are everywhere. But when it comes to developing and deploying microservices, there are quite a few challenges. First thing is, microservices is all about polyglot development. Developers choose best of the breed languages, tools, frameworks, and a variety of technologies to build multiple services that are assembled together as an application. So developing software in just one language, one framework in itself is pretty complex. Now you can imagine the complexity, the rise of complexity when you're dealing with a disparate set of tools, technologies, languages, runtimes, and frameworks. So it is highly polyglot and highly challenging. It's also distributed. Microservices will run across multiple nodes that act as a cluster. So obviously that makes debugging pretty difficult, because there will be multiple instances of the same microservice running across multiple nodes of the cluster. And each of the instance will be generating a lot of logs and profiling information, capturing that and taking action on some of the insights that are delivered by these logs and profiling output is going to be, again, pretty complex. And that's what I mean by hard to implement logging and tracing, because it's truly distributed logging and truly distributed tracing. Microservices typically scale in and scale out pretty rapidly. They are very dynamic. They actually implement auto scale. So you never know how many instances of a specific service will be running at a given point of time. And beyond that, these microservices use a variety of protocols, all the way from HTTP to gRPC to NATs to traditional RPC. We have a variety of protocols for microservices to talk to each other. And to really route the traffic and to make sure that the traffic is actually balanced, we use a variety of load balancers which are internal and also external. The public facing microservices like the API endpoints and web front ends will be behind a public an external load balancer, while internal services are behind an internal load balancer where the traffic gets routed to one of them. So to put things in a perspective, this is how we end up dealing with microservices. And one of the best practices of dealing with microservices is to create the agent or an SDK that actually sits next to each microservice. And the job of this agent is to make sure that it is intercepting the traffic, both the inbound and outbound traffic, as well as it is keeping track of the upstream services. So when one of the upstream services fails to respond correctly, the agent can take an action. It is actually called as the retry or the circuit breaking pattern. And similarly, because the traffic is flowing via the agent will be able to intercept a lot of telemetry, and this telemetry can be sent to a central monitoring service. Traditionally, this architecture was implemented by writing multiple agents. And when I say multiple agents, what I mean is every language, every service that is implemented in a specific language had its own agent. So if you are rolling out microservices that use Python, Java, C#, and Ruby, you'd be writing these agents that help you deploy and manage and scale these microservices in the same language. So you're going to maintain these agents over a period of time, and it is going to be very expensive and very cumbersome. Then these agents call home, which is a centralized monitoring service. And again, it's your responsibility to write that centralized monitoring service and maintaining it as the highly available layer, because all agents end up talking to this central monitoring service, which acts as a control plane. And then these agents also need to understand a variety of protocols, like I mentioned, HTTP to gRPC to GraphQL to all contemporary protocols. They need to integrate well with load balancers, both at L4 and L7 layers. And this is going to be pretty complex. Bottom line, writing these agents that are helping you manage microservices by yourself is very complex, cumbersome, expensive, and very laborious. So to alleviate this problem, we have a service mesh. So the service mesh has become very popular after microservices became mainstream. So a microservice, when it is actually running in the context of, let's say, Kubernetes or Mesosphere, or even in a set of VMs, will talk to the service mesh, which is going to plug itself into the intra-service communication layer. The best thing about a service mesh is it is not written for a specific language or a framework or a runtime. It is agnostic to any language, any framework, and any runtime. And it basically plugs itself into the communication layer, enabling microservices to talk to each other via this layer. And it typically intercepts east and west traffic, and in some cases even north and south traffic. And because this service mesh is going to sit next to every microservice in your deployment, it can effectively capture telemetry related to services and traffic. It also adds an implicit security layer, because the traffic goes via the service mesh layer, so it can actually secure the communication that takes place between two services. It also enables service discovery, which is a big problem in distributed computing. So you always have a well-known endpoint to look up to, and you can technically keep that well-known endpoint the same while replacing the backend services with different versions or even different implementations. But the endpoint will always remain the same. Service mesh also implements policy-driven routing and traffic management, and this is very powerful, particularly in the case of Istio. This is typically used to do things like blue-green deployments, canary releases, and managing multiple versions simultaneously and doing a staggered release of your application. Service mesh is not just confined to containers. It can technically get integrated with virtual machines and traditional line of business applications. In fact, some of the emerging technologies, for example, Google's Anthos is highly dependent on Istio, which is a service mesh, to actually implement hybrid connectivity between virtual machines and containers. So that is how service mesh is designed. It is a drop-in replacement to a DIY agent and delivers a lot of capabilities. At a high level, a service mesh does three things. One, it is responsible for intercepting the traffic and generate a lot of telemetry, which is delivering insights, number one. Number two, it can take control of the traffic and gives you a declarative mechanism to route the traffic across the communication layer. That is the second capability of a service mesh. The third capability is security. Even if you are not implementing mutual TLS or any of the security protocols, a service mesh can effectively secure your deployment. So those are the top three deliverables of a service mesh. So why do we need service mesh? Well, it uses an out of proc architecture. So it is a plug and play mechanism where you can simply plug a service mesh proxy to your microservice and everything happens magically. There's a clean separation between data plane and control plane. So there is a component that runs next to your microservice, and then there is a component that is responsible for aggregating, collecting, and implementing the policies. So that is the control plane. The service mesh supports internal and external load balancing across L3, L4, L7, and it delivers consistent service discovery, which is very important in the context of distributed computing. Service mesh supports a variety of protocols, including some of the protocols like MongoDB, Cassandra, and Amazon DynamoDB. So when you call any of these services from your microservice, it is transparent to the service mesh, and it can actually intercept the traffic and generate telemetry that's going to be extremely useful. The service mesh can perform health checks even before you make an outbound call. And in case you are trying to call a service that is not responding or that is not healthy, you don't need to make a call and wait for it to return an error. Instead, your service mesh proxy is going to proactively monitor the health check and will prevent you from calling a failing service. That is because of the health checks. Obviously, there is a real-time monitoring, logging, and tracing, which is very useful because the service mesh is going to sit next to your microservice. It can get a lot of insight from the traffic, the health, and the overall state of your deployment, and it uses that for real-time monitoring, logging, and tracing. And ultimately, service mesh is a part of distributed computing best practices. If you're going live, if you're actually deploying microservices in production, you need to have a service mesh. It is coming to that point where service mesh is becoming inevitable. It is as important as a container orchestrator. So this is the big picture of service mesh. You have proxy, which is going to sit next to every microservice. Then there's a control plane that is going to be the centralized aggregator and the policy implementer. So you basically talk to the control plane to define and push policies that are going to act upon one or more proxies. Similarly, every proxy will call control plane and it sends the metadata and the telemetry related to every microservice. And the service mesh is capable of dealing with multiple protocols, multiple load balancers, and even external services that are beyond the context of your core deployment. So that is a quick crash course on service mesh, and these are applicable to any service mesh that you would want to deal with, whether it is Istio or Linkerd or HashiCorp's Consul Connect. These are the concepts that you need to be familiar with. So what is Consul? Well, Consul has been around for a long time. It is a very mature technology. It is a service mesh that is providing a full stack, full featured control plane that delivers service discovery, configuration, and segmentation. The keywords here are service discovery. Consul is very effective in implementing service discovery in a distributed environment. The second one is configuration. You can actually configure the way traffic is routed, and you can also implement segmentation through a concept called intention. So those are the three deliverables of Consul. It is also a very popular key value database. So before HD became popular, Consul was preferred as an in-memory key value database, and because of its highly available control plane and highly distributed nature, a lot of applications actually relied on Consul for maintaining key value pairs in memory. So at a high level, Consul actually has the concept of a server and a client. So the server is going to be the control plane, whereas the client is the proxy that actually sits next to the service. So the server typically runs what is called as an agent, and this agent is highly available in production environments. The Consul agent can run across multiple servers, across multiple data centers, and it uses a protocol called the gossip protocol to basically maintain the state across multiple agents and multiple data centers. So it can run in the context of a LAN or even a WAN that is connected via VPN or over the public internet. When it comes to public cloud, you can think of it as a multi-zone and even multi-region control plane that can keep the state in sync. So the server is going to be the control plane, and that is going to be running in a highly available mode, whereas the client is almost like a proxy that sits next to every microservice and is responsible for intercepting the traffic, routing the traffic, and implementing the policies. So at a high level, Consul does a few things really well. As I mentioned, it's a fantastic service discovery platform. Even if you're not using the service mesh capabilities of Consul, you could still use it for service discovery. What I mean by that is when you publish a microservice in the registry, uh, that is going to be a well-known endpoint, and you can technically replace that endpoint with any other service or any other version of the same service without impacting the downstream component. So the call chain remains the same, while you can upgrade your components or services on the fly, without actually changing anything in the upstream and downstream call chain. And this service discovery can happen via DNS or HTTP. DNS is the most preferred because implicitly the caller can figure out how to basically discover the callee component or a microservice. It can also explicitly make a HTTP query, get the address, and then proactively make a call to the upstream service. But DNS is the most preferred, and it is a very natural mechanism of implementing service discovery. You can also do health checks. So every service is automatically tracked for its health, and you can extend this to implement a pattern called circuit breaking, which will avoid unwanted results in production. As I mentioned, Consul is a phenomenal key value store. It is a highly available in-memory key value database. You can use it to push a variety of data, which is going to be available to all the agents, all the clients that actually need to access, and it is going to maintain this in-memory. So it's going to be very fast. And Consul comes with a very minimalistic yet powerful web UI, and it lets you configure a lot of things interactively. And as I mentioned, it's a multi-data center deployment platform. You can run it on one machine or a set of machines or a data center or even multiple data centers. And in the context of public cloud, it could be a multi-region, multi-zone kind of a deployment. So that is about the theory, that is about appreciating the service mesh and a very high level overview and introduction to Consul, but things become much clearer when I jump to the demo. So what am I going to show you? Well, I have 3 RESTful services, not fancy. They are just 3 REST endpoints that do very simple thing. So once we deploy these RESTful services, we are going to configure service discovery. We will use Consul's native service discovery to publish endpoints that are more robust and more reliable than using the fragile traditional REST endpoints. Then we will go ahead and roll out the service mesh capabilities, and then we'll secure the communication through MTLS. And finally, I will show you how to apply traffic restrictions so that you can selectively route traffic to the services. You can either allow or deny. So Consul is a very minimalistic, simple, but very powerful platform. So I'm going to deal with three services, three microservices. We have a microservice called tax, and this is invoked by another microservice called invoice, and invoice is invoked by order. The order service never talks to the tax directly, but it actually makes a call via the invoice microservice. And our job is to basically implement a service mesh through Consul Connect for these set of microservices. So let's jump into the demo and let me walk you through what I have in store. So here we go. Now I have the terminal window, and Consul is a binary that you can very easily download and run inside a VM or inside your development machine. It's also available as a container, and it is also tightly integrated with Kubernetes. I'm going to do a follow-up session where I'll talk more about Consul's integration with Kubernetes, but to keep things very clean, I'm going to show you the command line interface that has nothing to do with containers, that has nothing to do with Kubernetes, but all the concepts that I'm going to demonstrate can be seamlessly extended to Kubernetes. All right, so let me walk you through what I have here. So I have the services directory. I have three services. So if you actually look at the number of Python files I have here, there is tax.py, there is order.py, and invoice.py. And if you're curious to look at the code, it is a no-brainer. Every microservice simply prints its name and its version. And this version is also hard coded, but in some of my other demos, I actually fetch it at runtime. And each microservice listens on a dedicated port. For example, the tax service is available on 5002. And by the way, this is a Flask REST endpoint. Then we have invoice, and invoice simply, excuse me, invoice simply invokes tax service by getting the environment variable. So we pass the environment variable to the invoice service, and it then figures out how to invoke the tax service. And this listens on port 5001. And finally, we have order. Order listens on port 5000, and it simply makes a call to invoice. So it's a call chain where order invokes invoice and invoice invokes tax, and they are they're not hardwired. We pass the URL of the upstream service via the environment variable. So let's go ahead and first launch these classic Python-based Flask REST endpoints. So I'm going to switch to my demo script, but before we actually go ahead and launch these microservices, I want to show you the infrastructure layer, which is going to be run by Consul. So Consul is already downloaded. As I mentioned, it's a binary that you can directly download from HashiCorp's Consul website. And once you have Consul binary, you can actually launch it from the command line. So I have already downloaded Consul and copied it to my path, which is /user local bin Consul. Now I'm going to launch Consul. So if you actually notice, when I'm actually running this, I'm passing a few switches. First thing is I'm going to run this as an agent, which means it is going to listen for all the traffic, and it is going to run as a part of the control plane. Then I'm passing the parameters -dev, which is very handy. This is not meant to be used in production, but if you are experimenting or prototyping with Consul, you can pass the switch called -dev, and this basically sets up an environment that is very development friendly. For example, it automatically brings up the MTLS backends, and it makes it ready for the service mesh. So we go ahead and add the dev switch and then UI, which will make it easy for us to access the dashboard. And then you can add a name to the data center. Assuming we are running this in a multi-region public cloud environment, I'm calling this in as a zone 1. And we can also give the name for the node. So I'm calling this as host 1. So we'll go ahead and launch Consul. So Consul is now running. If you actually notice, it is currently listening. There are no errors, and it is currently available on a set of ports. So now Consul is running. We can actually verify this with a couple of commands. For example, I will now run this command Consul members, and it shows us that the node is host 1, data center is zone 1, and it is currently running on port 8301. And if I have multiple agents running in multiple machines or across the data center, all of them will show up here, and they automatically discover each other, and they keep in sync via the gossip protocol. So that's about verifying that the Consul agent is up and running. We can also run this curl command, which will basically hit localhost 8500, and it shows again the same information but in a more JSON friendly manner. And this is how you can programmatically enumerate all the agents available as a part of your Consul deployment. So now that Consul is up and running, you can also implement DNS. So when we actually do a dig, and notice that I'm pointing the port 8600. So when I actually try to resolve host1.node.consul, it actually shows up in the standard DNS format, and it is an indication that Consul is running a parallel DNS server, of course, on port 8600. So now the Consul infrastructure is up and running. What we can do is go ahead and launch our services. So now it's time for me to launch the first service, and tax.py doesn't have any backend. That is, it is basically the last service in the call chain. So we don't need to pass anything. So we'll first launch tax.py, and this is listening on port 5002. Then I'm going to pass the URL of the tax microservice and launch invoice. So now invoice is up and running, and with that in place, I'll go ahead and launch the order. And for order.py, I'm actually passing the URL of invoice again as an environment variable. So now we have 3 microservices up and running. Technically, you may argue they are not microservices, they are just Flask endpoints, but if I wrap them in a Docker container and run them as a pod and a service in Kubernetes, it actually becomes a microservice. So technically, they are still microservices. So now with these in place, I can go ahead and do a curl on localhost 5000. And as we expect, we are invoking order, and order will invoke invoice, invoice will invoke tax, and that's how the entire call chain is happening. So that's how we are able to see the output. Fantastic. So this is great. But at this point, if you notice, the microservices have no clue about Consul, and Consul doesn't even acknowledge the presence of these microservices. So what we need to do is basically make sure that we are registering these microservices, and we should actually make Consul understand these microservices. So how do we register our microservices with Consul? Well, it is pretty straightforward. So what we'll actually do is we'll come back, we'll kill the Consul service with Control-C, and now it's time for us to register our 3 services with Consul. So how do we do that? Well, there is a folder that I have created. It's called consul.d, and it has exactly 3 JSON documents. Now let's go ahead and open them. So these JSON documents represent each of our services. So there is order.json, and if you notice, order.json is just the definition. It basically says the service name is order. I can have arbitrary tags just to resolve them with different identities, and I'm registering the port saying that order is listening on port 5000. Same thing is applicable to invoice, and then we have tax. So basically this simple JSON doc will register our existing services with Consul. So now what I'll do is I will relaunch Consul, but this time passing a parameter, a switch called config dir. So config dir will pick up all the JSON documents that are available in this directory called consul.d, and that is how we basically register our services. So now you'll actually notice that the agent is syncing the services called invoice, order, and tax. So this is how we basically connect Consul with a set of existing microservices. Excellent. So now that it is done, we can start resolving the service names. You know, one of the very important aspects of Consul is service discovery. So again, we'll use dig and take a look at the order URL. Now, one thing that I want you to understand is the moment you register a service with Consul, it automatically becomes visible on a well-known endpoint, and it is typically the name of the microservice or the tag of the microservice that you have used in the JSON document, followed by .service.consul. So rest assured, every service is bound to resolve with this endpoint. So we can verify it by running this dig query. And now if you notice, it actually comes back with a response that says order.service.consul is available on port 5000 and it is available on this host. Now, in case you're actually running a multi-node, a multi-data center deployment of Consul, it also comes back and tells you which host is basically responsible. But the beauty is any service can simply talk to order.service.consul and it gets redirected to one of the physical hosts on which the actual service is running. You know, that is the advantage of using service discovery. Later on, if you want to launch order on a different Consul node in a different zone or part of a data center, the upstream services don't even understand that, you know, they're basically they're talking to a different service that is listening in a different environment. So that is the advantage of using service discovery via Consul. So similarly, let's explore invoice. Invoice is listening on 5001, and similarly tax is listening on 5002. So now this is an indication that the service discovery is kicking in, and we can now use the well-known endpoints rather than using the hardwired, you know, localhost colon port number or host colon port. So instead of using the DNS, you can also run a simple HTTP GET request, and it shows a very well formatted output. You know, when you're actually querying for, let's say, the order service, it comes back and tell you everything about the order service. So, you know, the service port is 5000. It is currently available on host 1. The address is this. So basically the same thing that DNS would return, but this is more verbose and more API friendly. So you can actually consume this in your code before you actually make an outbound call. So you can also do the same thing for invoice and tax and so on. Now, one of the things that I mentioned is the UI element of Consul, and very minimalistic but very powerful. So this is the home page. So zone 1 is actually the data center, and if you look at the nodes, there is only one node which is called host 1, and there are 3 services. Of course, it is tracking Consul, but beyond that we have registered 3 services: order, invoice, and tax. And we have also added tags. And remember, you can also resolve a microservice by its tag. You can arbitrarily pick up a tag and add .service.consul and it will resolve. So this is how we can visualize through the dashboard. You can also have key value pair. You can actually create an arbitrary key value pair. There is a limit to how big the JSON document could be, but you can have any number of key value pairs stored in memory that you can query programmatically from your services. Phenomenal. So that is the first part where we are using Consul for service discovery. Now what I've done is I actually added a file on my Mac, and that file is /etc resolver /consul. And when I actually add name server as localhost port 8600, I'm actually asking my machine to include this for the DNS resolution. This simple entry in Consul file under the resolver directory will supplement my existing DNS service by resolving the names directly. How do we know that? Well, we can actually query um, using the uh, using the service discovery endpoints. So let's actually try this. So I'm going to kill all the services. Let's leave tax as it is because there is nothing to be passed to the tax service. It is the last one in the call chain. But what I'm going to do now is instead of using localhost colon 5002, I'm changing the tax service URL to the Consul endpoint, which is tax.service.consul 5002. So I'm launching invoice with the new tax endpoint, tax microservice endpoint. Similarly, I'm launching order service with the endpoint provided by Consul. Now, we are not using the default host colon port. Instead, we're actually using the service discovery endpoint as registered with Consul. Now, with that in place, we can go ahead and run this query. Now I'm actually using order.service.consul 5000, and everything works like a charm. Now, what is the difference between the previous curl request and this? Well, I can technically go ahead and change the service that is listening on this and my clients will continue to work. So that's a nice decoupling between your caller and callee without changing any line of code, any piece of configuration. So that is service discovery for you, which is one of the first capabilities and first features of Consul. So just to quickly summarize, I'll take you back to my slide. So tax, invoice, and order, 3 independent microservices are now registered with Consul, and the outcome that we had with this exercise is the automated service discovery and health checks. So if for some reason one of the ports is not responding, Consul will automatically figure that the health check is not green and it automatically turns red. So that is another advantage of using Consul with your microservices. All right, so that completes the first part of my demo. Now we are entering the second part where we'll extend this to implement a service mesh. So let me come back and kill these services because we are going to launch them again with a different configuration. So now what we're going to do is to basically extend the power of Consul to Consul Connect, which is the service mesh capability. And to do that, I'm going to run Consul with a new config directory called consul mesh.d. So the number of configuration files there are slightly different, not the number, but the actual definition and the configuration. So let's take a look at the files here. We exactly have the same number of files, 3 JSON files representing 3 microservices, but their definition is much more elaborate. So let's start from order. So if you look at order service, it exactly remains the same. There is a name to the service, there is port, but we actually go ahead and add something called sidecar service proxy. And here we are adding a couple of entries, couple of nodes to this JSON document. So one is we are actually saying that the upstream service is called invoice, and invoice will be available on 6001. This is actually not the invoice service, but this is the proxy of invoice. So that's what is being mentioned in the service definition. So now what this basically tells Consul is when you are registering the order and invoice, make sure that the invoice service is listening on the proxy of invoice is listening on 6001. Now we do the same thing for invoice. We register the actual service and we tell that the proxy is going to be calling an upstream service called tax, and this tax service should be available on 6002. And then obviously when it comes to tax, the sidecar service and the proxy is empty because it doesn't end up calling any other backend service. But every time you have a backend service, you register that here and you explicitly mention the port on which you're going to expect the service. So now we have not only registered the services, but we have also gone ahead and implemented the proxy and the sidecar for each of the microservices. And this is where we actually take advantage of the service mesh capabilities. All right, so now what are we going to do? Well, let's launch the services again. So, we are still using the Consul service discovery endpoint. So tax service is up and running. Then we launch the invoice and then the order. So we have all the three services up and running, and we can query any of this and it should still work. So okay, so this is not going to work because we just changed the configuration and we need to update the port. So I'm coming to that in a second. So now we have the updated JSON docs with updated configuration. So what we'll do is we'll actually launch Consul agent all over again, but this time with the updated JSON configuration. So now it is actually going to kick off the service mesh, but it also reports that there is an error, there is a warning that the sidecar proxy is not running. So what you need to do is, this is only when you're actually doing it manually, but when you're doing it in Kubernetes or Docker or in an orchestration environment, you don't need to launch these sidecars manually. But for now, you actually need to launch the sidecars manually. So what we'll now do is use the Consul Connect proxy and launch the sidecar for each of our service. So first we launch a sidecar for order, and then we will launch the sidecar for invoice. Okay, and then we launch a sidecar for tax. Now what it actually does is that the sidecar will now become the actual interface for all our services, and at this point Consul will stop reporting any warnings or errors because everything is in sync. So now the way it actually works is that there are three services and each service is now attached to a sidecar proxy, and we can again verify this when we come back to the dashboard and refresh it. So when we refresh, we actually notice that there are additional services that are available as proxies. So now you'll actually notice that this is a proxy, and this is listening on a specific address. It is passing the node check and service check. Similarly, for every other service, there is a proxy, and that is an indication that Consul Connect has now injected a proxy into the data plane, and every outbound and inbound call will go via the proxy. All right, so now we have a full-blown configuration, Consul up and running with the sidecars up and running. We have three sidecars that are associated with all the three microservices. Now this is a manual step if you're doing it from the command line or inside a VM. If you're actually doing it as a part of Kubernetes, all of this is going to be automated. So don't think you have to do a lot of configuration in real world cluster environments. Not really. This is a very detailed, more verbose mechanism of launching Consul and Connect. All right, so now that we have the services, the proxies and the control plane up and running, we can now switch to a more secure URL, and the secure URL is this. So till now we have been using the port with 5000 series, right? So we have been using 5002, 5001 and 5000. Now what we're actually going to do is to switch to a more secure version of the endpoint, and this secure version of endpoint is exposed via the proxy, and it is available as 6002. But where is the 6002 coming from? Well, that's what I defined when I actually had the JSON document responsible for registering the sidecar. So let's go ahead and launch invoice. So this is okay. So tax is up and running. Now I'm going to kill the invoice and launch it with the sidecar. Basically, instead of talking to the default endpoint, we are asking this to talk to the sidecar proxy endpoint. And similarly, I will go ahead and launch my order.py by passing the invoice URL. But again, I'm pointing this to the sidecar, which is which is acting as a proxy. So now we have all the three services running, but they are now talking to different endpoints, not the default endpoints on which they have been programmed to listen. And this traffic is now handled by Consul Connect. So technically, when I actually run this query, nothing changes. It is still the same. So when I run this, it is exactly the same. But the beauty is when I call order is talking to invoice, but it is not directly talking to invoice. It is talking to the proxy, and invoice is talking to tax again via the proxy, and everything else remains the same. So that's the advantage of having a sidecar, which is completely independent of your microservices. So if you notice, we haven't changed the code, we haven't changed anything except relaunching Consul and launching the sidecars. And as I mentioned, if you are using a container orchestrator like Kubernetes or Docker or Nomad, you don't even need to do that. It is handled by the orchestration engine, and all the steps that we have taken will be completely automated. All right, so now we have looked at the second part where the data that is flowing across the microservices is secured. So if you actually look at this, there is a TLS identity associated with every service. For example, the invoice service is now associated with a TLS certificate, and same thing with the order and tax. So every service is now associated with a TLS endpoint, and that is what is is being used for secure communication. So that is the second part of Consul that I want to demonstrate. The first was service discovery. The second one is using the mesh technology for implicitly securing the data plane. All right, now what I actually want to show you is pretty interesting. And this is what is actually called as intentions. Now, by default, the call chain is invoked in a sequence, right? But for some reason, if I want to avoid order calling invoice or order directly calling tax, I can actually implement a policy, and that policy in Consul's terminology is called as an intention. And these intentions are basically very simple. Either you allow a microservice to call the other, or you deny the microservice to call the other microservice. Pretty straightforward. So we can start with this command called Consul intention check order invoice. Now, what this basically returns is whether order can invoke invoice, and currently it is allowed. So what we can actually do is we can also check whether invoice is allowed to call tax, and it is absolutely allowed. Now what we'll do is we'll actually create an intention that denies the traffic from invoice, the traffic originating from invoice and targeting tax. So we are now denying the traffic. And if you actually go back and check this, it says denied. Now it's going to be pretty interesting. When we actually invoke order, it's going to fail. And it is obvious because, in the call chain, we have now order trying to invoke invoice, and invoice is not allowed to talk to the proxy of tax. So it actually breaks here, right? Very powerful concept. Now I can come back and I can actually say delete the intention. So now we are deleting the original intention of denying. And now if you actually say check invoice to tax, it is allowed. And when I invoke this endpoint, everything works like a charm. Again, completely declarative. and you don't need to touch one line of code. So let's now create a rule, to deny traffic originating from order and going to invoice. So now this is denied. So when I actually invoke order, it again fails, obviously, because order is now failing and it doesn't even go up to invoice. So again, we'll go ahead and delete this intention, which means we'll allow the traffic, and then we can check whether everything is working fine, and it is working fine. So that is the advantage of using Consul intention. When compared to Istio or Linkerd, Consul is very simple. It doesn't overwhelm you with a lot of complexity, lot of configuration, lot of concepts. Pretty straightforward, simple, but achieves the objective of a service mesh. One final thing that I want to show you is the GUI for creating the intention. So you can actually use the web-based dashboard to create the intention. So you can actually say deny any traffic. You can actually use the wildcard, which is star, deny any traffic to tax, right? And deny traffic to tax. So now this is exactly the same as using the command line in our previous exercise. So now, when we actually create this, when we try to invoke, obviously this fails again because we have a policy there. You go ahead and delete. This is a nice GUI for the same command line interface that we had, which is also available as an API. Now everything works well. So those are the capabilities of Consul. We looked at 3 core capabilities. We looked at service discovery, where every service registered with Consul automatically gains a well-known endpoint, which is service.consul. That is the first thing that we have looked at. The second thing is, of course, the whole power of service mesh and securing your traffic by implementing a sidecar proxy. That was the second thing. I have demonstrated how to use intentions as a mechanism to apply policies, and that was the third capability of Consul. So that was a quick walkthrough. I hope you found this useful. Now, before I move to the Q&A, I want to announce what's coming up next. I'm pretty excited to bring the cutting edge technology, which is just announced by NVIDIA. This is like a couple of months old. It's called NVIDIA Jetson Nano. This is an edge computing platform that comes with a GPU, that comes with an NVIDIA, the Jetpack SDK, the TensorRT runtime, and the ability to perform accelerated inferencing of AI models. So it's a pretty powerful system on board computer. And I'm going to walk you through everything from setting it up to performing inferencing and running some demos to perform object detection, image classification, and face detection. So it's going to be a pretty interesting session. This is going to be on July 11th, same time, and you can sign up at mi2.live. I also want to thank our sponsors, the NewStack, our media partner. You'll find the supplementary content, the tutorials, the concepts, the background of every session at the NewStack. Foghorn, a Bay Area-based edge computing company that is attempting to be the multi-cloud AI at edge platform. Portworx, another Bay Area container native company. I want to thank our sponsors for supporting me with the infrastructure and enabling me to do these sessions. So that brings us almost to the end of this, but I want to pull up a couple of polls. So while I'm looking at the questions that you may have, let me know what you think of this session. Excellent. So most of you, almost 100% of you said the content was very relevant. That's very encouraging. Now, how do you rate the overall quality of the webinar? This includes everything from your audio visual experience to my presentation, my ability to deliver, the quality of demos, everything. All right, very encouraging. Most of you felt it is excellent and some of you felt it is very good. Thank you for sharing that feedback. And now let me take a look at the questions. And it looks like we don't have a lot of questions. There are some mundane questions like, will the recording be available? Absolutely. That is going to be on my YouTube channel. You can visit mi2.live and that will take you to my YouTube channel. You can access previous content, previous sessions, and this one would be up and running in a day or two. And don't forget to check out the newstack.io, where I'm going to write a detailed step-by-step tutorial on performing service discovery, sidecar proxies, and intentions. So you'll actually find the entire demo script and step-by-step guide at the new stack. So that brings us to the end of this session, and I'm going to see you in a couple of weeks where I'm going to demonstrate NVIDIA Jetson Nano. So if you are following the cricket match, go back and track the score. India is doing pretty well, and I'm very hopeful they're going to be in the semifinals. And have a great rest of the week ahead. I'll see you in the next webinar. Thank you.